Welcome to this explainer. I am so thrilled to have you here today because we're going to demystify something absolutely massive. And I mean literally massive. We are talking about the technology that's quietly, efficiently, and securely connecting billions of devices all over the globe, right? Like, if you've ever wondered how a sensor in a remote farm, or maybe a smart meter buried deep in a concrete basement, or even an animal tracker out in the wild actually gets its data back to the people who need it, well, you're in the exact right place. Today, we are diving deep into the world of LoRaWAN. To give you an idea of where we're headed, here's our quick roadmap. First, we'll look at the IoT challenge. Second, we'll clear up LoRa versus LoRaWAN. Third, we'll get into the architecture and device classes. Fourth, we'll cover the big benefits and security. And finally, we'll see how it's actually changing the world today. All right, Section 1, understanding the IoT challenge and how we actually go about connecting 25 billion things. Okay, let's dive right into this. To really appreciate what LoRaWAN actually does, we first kind of have to wrap our heads around the sheer scale of modern digital transformation. We're looking at a world with over 25 billion connected objects right now. Just think about that number for a second. Now you might be wondering, hey, don't we already have Wi-Fi and cellular for that? Well, yes and no. See, Wi-Fi is great for moving a lot of data, but it has super short range. Cellular, 4G or 5G, has incredible range and speed, but man, it drains batteries incredibly fast, and the infrastructure is super expensive. So if you've got thousands of tiny sensors spread out across miles of rough terrain, neither of those are going to cut it. There was just this massive gap in the market for something that could go the distance without killing the battery.
But hey, before we go too far down the rabbit hole, let's just make sure we're on the same page about what those 25 billion objects actually are. We're talking about the Internet of Things, or IoT. At its core, IoT just means sensors collecting data and devices talking to each other, completely without human intervention. So smart water meters, soil sensors for agriculture, asset trackers, that kind of thing. These devices, they don't need to stream ultra-high-definition video, right? They just need to send tiny little packets of data, maybe a temperature reading, reliably and efficiently. And that exact communication gap, that's what LoRaWAN was built to solve.
Moving right along to Section 2, LoRa versus LoRaWAN explained. Let's understand the layers. So, if you've spent any time in this space at all, you've probably heard both of these terms used interchangeably. But actually, they aren't the same thing. The absolute easiest way to think about this is with a quick analogy. LoRa is the physical layer. It's the actual radio technology that sends the wireless signals using this thing called spread spectrum modulation. Basically, think of LoRa as the road. LoRaWAN, on the other hand, is the MAC layer. It's the communication framework. It's the network protocol that actually manages all those devices, dictates the data rates, and keeps an eye on security. So, if LoRa is the road, LoRaWAN is the traffic rules. And this brilliantly illustrates exactly how they stack up together. If you look, you've got that LoRaWAN MAC layer sitting directly on top of the LoRa modulation physical layer. The bottom layer is out there handling the raw radio frequencies in regional bands, like EU 868 or US 915, to create that really long-range communication link. But it's that top layer, the LoRaWAN layer, that acts as the real networking protocol. It's the brains, making sure everything actually functions as a cohesive, secure, and manageable network.
Okay, Section 3, Architecture and Device Classes. Let's look at the data flow and the different classes.
Now that we've got the definitions locked in, let's zoom in a bit further to see exactly how the data flows from a remote sensor all the way to a dashboard on your screen. Now, what's really interesting about this is what we call the star of stars topology. So picture a smart trash container in a city park. It senses that it's full, so it sends out a LoRa radio signal. But here's the cool part. That single signal doesn't just go to one router like your home Wi-Fi does. It can actually be picked up by multiple gateways in the area, all at the same time. And those gateways, they act as transparent bridges. They just take that radio frequency packet and securely forward it over a standard IP connection, like cellular or Ethernet, straight to a central network server. Then the network server does the heavy lifting. It cleans up duplicate messages, checks the security, and hands it off to the application server so the waste management company knows, hey, it's time for a pickup. Let's actually move to see how this builds out systematically across the four main steps. Step 1, the end device, our sensor, collects the data. Step 2, the gateway receives that packet via LoRa radio frequency. Step 3, the network server processes the packet via a standard IP connection. And finally, Step 4, the application server displays the info so a human or even an automated system can take action. It's really just a highly elegant, highly scalable four-step journey. But, not all devices have the same job, which is exactly why LoRaWAN defines 3 specific device classes. Class A devices,
Those are your battery-operated sensors, like our smart trash bin. They use the absolute lowest amount of power because they literally only wake up to transmit data, briefly listen for a response, and then go right back to sleep. Then you've got Class B devices. These add scheduled receive windows, which is absolutely perfect for something like smart irrigation valves that need to be turned on with maybe just a few minutes of latency. And finally, Class C devices. These guys are continuously listening for a network ping. Because they never sleep, they obviously require continuous external power. So they're ideal for applications like smart street lighting, where you really need instantaneous control.
All right, moving to Section 4, Powerful Benefits and Security, and exactly why LoRaWAN dominates this space.
Now that we've kind of peeled back the architecture, it becomes a whole lot clearer why this specific technology is absolutely dominating the massive IoT market. So the crucial point is really summarized in these mind-blowing specs. We are talking about a range of up to 15 kilometers in rural areas and even up to 5 kilometers in super dense urban environments. And remember those Class A devices we just talked about? Because they sip such a tiny amount of energy, their batteries can last 10 to 15 years without ever being changed. No way, right? But honestly, perhaps most impressively, the sub-gigahertz LoRa signals provide this really deep indoor penetration. I mean, they can reach utility meters in basements, elevator shafts, even underground parking sensors, going straight through thick concrete barriers. And all of this is achieved over unlicensed radio bands, which basically means massive scalability with surprisingly low infrastructure costs.
But, of course, none of those amazing benefits matter to a major enterprise or a smart city if the network is vulnerable. Right? So we have to ask the ultimate question, is the data actually secure? Because businesses simply will not deploy tens of thousands of sensors if it means literally opening a back door right into their infrastructure.
Well, the answer is a resounding yes. LoRaWAN was created with security top of mind from day one. It definitely isn't just an afterthought tacked on later. It is secure by design. The protocol uses industry-standard AES 128 encryption. Plus, it features 2 distinct layers of security. You have network security, which makes sure the node is actually authentic, and then application security, which ensures that even the network operator can't see the end user's actual application data. Every single device has to undergo mutual authentication to even join the network, which guarantees complete end-to-end encryption and integrity protection. So, yeah, it's locked down.
And finally, Section 5, Changing the World Today. Let's talk real-world impact.
Let's step away from all the technical specs for a minute and look at the incredible impact this is having out there right now. The applications of LoRaWAN are quite literally endless, and they are amazingly diverse. On the industrial side, it's slashing utility maintenance costs with automated meter reading, and even predicting industrial equipment breakdowns before they ever happen. But, it goes way beyond the factory floor. LoRaWAN is currently being used to track vast reindeer herds out in the wild. Seriously. It's even being used in smart street lighting networks near beaches. They dim the lights at specific times to help newborn baby sea turtles safely navigate their way out to the ocean. I mean, from deep industrial optimization to protecting endangered species, this tech is actively working in the background of our world every single day.
And I think the LoRa Alliance really hit the nail on the head when they said, LoRaWAN improves health, safety, and welfare for all citizens while also improving businesses' bottom lines. And that right there is the true power of this technology. It doesn't force you to choose between operational efficiency and making a global impact. It literally delivers both simultaneously. By giving us this unparalleled visibility into our physical world, we can conserve resources, prevent accidents, and streamline logistics at a scale we've never seen before.
Well, we have covered a massive amount of ground today, from the physical road of LoRa to the traffic rules of LoRaWAN and that whole Star of Stars architecture that makes it all possible. Knowing that you can now securely send data up to 15 kilometers through solid concrete on a battery that lasts over a decade, I want to leave you with one final thought. Take a look at your own business landscape, your own logistical hurdles, and your own data blind spots. How could the incredible power of massive IoT and LoRaWAN revolutionize your own industry? Thank you so much for joining me on this explainer, and I really hope it sparks some exciting new ideas for you. Catch you next time.